class and Thursday, and then next Tuesday and Thursday for statistics. And excuse me, I have to sneeze. Your exam is the week of Thanksgiving. If you have a Monday, Wednesday class, exams are on Monday. And if you have a Tuesday, Thursday class, your exam is on Tuesday. So the exam for this class is on Tuesday, and the exam is during regular class time. So you are expected to be available to take the exam during the 10:45, 12:45 time period. The exam will not be any time during the day. You do have to take the exam during class time. So you need to be sure you're making arrangements now in your schedule so that you are available to take the exam during that time frame. Okay, so if you work or you're going to travel or whatever, you need to be sure that you are available to do the exam during that time frame.
I have a question.
Yes, sir.
What type of problems are going to be like on the exam? Everything we have learned?
Yes, the exam will be cumulative. Okay. It will cover all 4 units. All right.
Thank you.
Anything else?
I have a question. So say you have like a bad grade, and like you do like really well on the exam, that like bump your grade up by like a lot.
Well, the exam is, I forgot whether it was 10 or 15% of your grade. So whatever your grade is overall, that's how it's going to affect your grade. It's a percentage of your grade. So it's not going to break, shouldn't fail you, but it should boost you. It could boost you a letter grade. Okay.
Appreciate it.
All right. That's kind of how it works. Same thing with attendance. Attendance won't fail you, but attendance could, boost you a letter grade as well.
You haven't placed like our attendance and our grade, or have you?
Yeah, they are in there now. It is working in the calculation, so it should be showing in your calculations. And for some reason on your, I've tried to get your averages to show, your current average to show on Brightspace, but I can't get it to display your current average so you can see that. I can only get it to show your current scores for particular items. That's all I can get it to show right now. So that's all that you have. But you do have your percentages for the categories. So you could manually calculate your averages. You have that in your syllabus for what each category represents. So like, your quizzes are 30%, your assignments are 30%, your attendance is 10%. So anyway, you have those percentages, so you could manually calculate. Like what you would do is find your average in each category and then do the percentages to get your total average. Okay?
Appreciate it.
All right. Any other questions before we start? You kind of know about the exam. It is cumulative. It will be on Tuesday before or the week of Thanksgiving. It will be during class time. So you need to be available during that time to take it. It's not something that you can do anytime during the day. So you do need to be sure that you are available during that time for it. Okay? It is online. It's not something you have to come to school to do. It will be online. All right? Okay, I'm going to flip over to the note sheet. Let me know if you can't see something. All right, in this last unit, I left a lot of the information up to you individually to work on because I felt like it was pretty much a review for most of you. You've seen it before. It was just a matter of review to pick it up and remember it again. The unit's been on functions. One of the first things to think about was what was the difference between a relation and the function. And you certainly want to be able to distinguish the difference between a relation and a function on the test. So you might have a couple of questions that will ask, is this a function or is it a relation? In particular, we focused on graphs and equations in terms of looking at what makes it a function, what makes it a relation. A function is in particular when the x value does not repeat. Y's can repeat, but the x value does not repeat. When we talk about functions or relations, we talk about domain and range. Domain being the input, range being the output. Generally, in terms of functions, we talk about x and y, domain being the x and the range being the y. It doesn't have to be that way. That's just the practice or the standard way to write things, but it doesn't have to be done that way. We've talked about methods to write domain and range. So be sure you are familiar and are able to do that. For most of you, that was reviewed to be able to write the list. If you're given a table of values, you certainly can make a list of the domain and range. Using set notation, that should be familiar with you, where we did that in sets. So that was kind of a review. For some of you, using interval notation was new. For some of you, it was not. But that is a valid method of writing domain and range. Just to kind of go over an example that you might see. If you had a problem and you were asked to give the domain, if I just wanted to describe the domain of this graph is extending on each end, so the domain is extending on each direction. So the domain is x is a member of all real numbers. If I was writing that in interval notation, I would say x is going from negative infinity to positive infinity. And anytime I'm using infinity symbols, I'll use the parentheses around it to express that. For the range, for this particular graph, it starts at this point and goes up forever. So for the range, I would say the value at this point is -2, and it goes up forever. So y is greater than or equal to -2. So I can use inequalities to express domain and range. If I was using interval notation, I would say the lowest value is -2 going up to positive infinity. We generally put the smallest value on the left up to the highest value on the right. If it is equal to the value, we use a bracket. If it wasn't equal to -2, we would just use a parenthesis. Since it's infinity on the right side, we always use a parenthesis with infinity. So that's just a quick example of looking at methods to use to write domain and range, in particular using some interval notation. So you do need to be familiar with that interval notation and how to use that for the test. I want to point out to you special cases for domain and range. You may be asked to give domain and range for any kind of function. You have that handout that is for characteristics of all types of functions. That is posted on Brightspace, so that is a good handout to have ready for the test. If you want to print that out just to have available for the test, but in particular for domain, special cases involve square root functions. The square root functions, the domain has to be greater than or equal to 0. That is a special restriction that you have to think about. So if we had a problem that was y is equal to the square root of x plus 2. To find the domain for that, we would have to think about that restriction. X plus 2 has to be greater than or equal to 0. That is the special restriction for that problem. And then we solve for x. So x has to be greater than or equal to -2. And so that is how we figure out what the restriction is for that domain. Another special case is for rational functions. That restriction is that they cannot equal 0. So for those particular functions, an example might be that y equals 2 over x minus 5. And so that denominator cannot have a 0 in it in a rational function. So we have to look at that restriction. X minus 5 cannot equal 0. And so we solve for x. So we add the 5 over. And so x cannot equal +5. So that is a restriction that we have to put for rational functions. A third case for domain is logarithmic functions. And for logs, the restriction is that they have to be greater than 0. So if we had y equals log of x plus 5, then we would have to make the restriction that x plus 5 has to be greater than 0. And so x has to be greater than -5 for that restriction. So those are 3 special cases in particular to look at for domain. In reverse, or in addition to, I should say, for range, special cases, again, with square roots, we have to be greater than or equal to 0. For quadratics, we have to be greater than or equal to 0. For absolute values, we are greater than or equal to 0. For exponential functions, we are greater than 0. And then for rational functions, we are not equal to 0 again. Now, rational functions do have some other restrictions, but the only ones that we're going to look at in terms of our class is the ones not equal to 0. There are other situations involved, but we're only looking at the one involved in not equal to 0. If you take a higher level math, you would go more in detail about the rational functions. So those are the special cases about looking at domain and range that you need to know in terms of the test tomorrow. Any questions there? All right. Next part of your functions, you focused on linear functions. So what were the kinds of things that you needed to know about linear function? One of the first things that you needed to know was about slope. And so slope has to do with the steepness of the line. So when you looked at the graph of the line, you should be able to describe the graph as increasing. Always read your graph left to right. Decreasing. Horizontal. Or vertical. So those are the 4 situations that you can find for slope of a linear function. If it is increasing, the slope will be positive. If it is decreasing, the slope will be negative. If it is horizontal, the slope will be 0. And 0 is different from no slope. That is a different answer. So don't put no slope when it is 0. When it is vertical, it is considered undefined, and you can put no slope there. Since it is the steepness of the line, we also can refer to slope as rise over run. How far do you go up over how far do you go left or right? Now, what else do you need to be able to do with slope? You need to be able to find slope using 2 points. So that means for tomorrow's test, you need to be sure that you have that formula available. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You need to be sure you have that formula in a good location that you can find and know how to use it. You want to be able to find slope using a graph. So does that mean that you pick 2 points from a graph or you count rise over run? I don't care which method that you use. You can do whatever works for you. You also want to be able to find slope from the equation. Now, the simplest way is if you have the equation in the format y equals mx plus b, where the m represents the slope and the b represents the y-intercept. Now, not all equations are in that format, so you have to know how to manipulate the equation to get it into that format if it's not already in that format. Other things you should know about slope has to do with parallel lines. If you have parallel lines, you need to know that the slopes are equal. So if you know the lines are parallel, you know they have the same slope. With perpendicular lines, it's a little bit different. These have opposite reciprocals. Their products equal -1. So if you took the two slopes and multiplied them together, you'd get the product of -1 if they are perpendicular. Dealing with linear functions, you also had your different equation formats. Of course, as we already talked about, your slope-intercept format. You also have your standard form. You have your general form. Notice there is not a great deal of difference between standard and general. It's just the position of the constant value, whether it's on the same side with the variables or on a different side. The letters A, B, and C represent coefficients of the terms. And then you have the point slope format, which allows you to be able to easily find the equation of a line when you know a point and slope. One of the things that you're going to have to be able to do on the test is to be able to find the equation of a line. Typically, this point slope format is one of the best techniques to use to do that. Not everyone likes to use that, but that is one of the easiest ways to find the equation of a line. And last, you should be able to use an application problem in any of these things that we've talked about in terms of linear functions. Any questions about linear functions? Anything that you want me to go over more in depth? All right, your last topic with functions were your quadratics. So what kinds of things do you need to know for your quadratic functions? First of all, one of the things you need to know is about the symmetry. When you look at a quadratic, if we drew a line down the middle of a quadratic, it would mirror each other on each side. So we call that line the line of symmetry. This point at the center of the parabola is called the vertex. And the line of symmetry goes through the vertex. The shape of the graph for a quadratic is called a parabola. The line of symmetry is written by the equation x equals h. This vertex is represented by the ordered pair h, k, the x value being h from the vertex. So if you're asked to give the equation of the line of symmetry, it's always going to be x equals the value of the h value of the vertex, which is the x value. Vertical lines, x equals that number. You should be able to identify transformations with the quadratic. You should be able to use the format of the vertex equation. Where the A tells us whether it shrinks or stretches. The H value tells us whether it shifts left or right. The K value tells us whether it shifts up or down. The sign of A tells us whether it reflects the x-axis. If it becomes negative, it flips the graph upside down and it reflects the x-axis. So these are things or skills that you have practiced in problems dealing with quadratics that you should be able to do on the test. Any questions on those? Also, in terms of the sign of the quadratic, you should be able to determine if the quadratic opens up or down. And you should use the terminology concave up or concave down. And this again has to do with the sign of the leading coefficient, which we call the A value. If it is concave up, that A value is positive. If it is concave down, that A value is negative. We also talked about different kind of equation formats with the quadratics. We had the vertex form. We can easily pick out the vertex HK when it's in that form, which helps us to graph the equation. It helps us to tell lots of things about the equation. It helps us to identify transformations. But we also can find quadratics in general form or in standard form. Again, general and standard form are not very different. It just has to do with that constant value C and the location of that constant value. One of the skills that you need to be able to do is to change the equation from one form to another. Now it's pretty easy to go from vertex form, where you just have to multiply the square part out and then distribute in order to go from vertex to general form. It's a matter of moving the constant term to go from standard to general or general to standard. The tough part is changing from general or standard to vertex form. And that's where you're going to use that little formula, x equals negative b over 2a, when you want to change from general to vertex. So that's another little thing to write down and have. You might want to make yourself a little formula sheet to have for the test tomorrow, so you have everything in one location. This gives you the x part. In order to find the y part of your vertex, once you find this answer, remember you substitute that into the equation in order to find the y part. And that gives you your h and your k in your vertex form. You want to be able to find your intercepts, whether it's your x or your y intercepts. Remember, if it's y, you just let x be 0 and plug it in and find y. If it is the x-intercepts, it's a little more involved. To find the x-intercepts, you want to know how to factor to solve. So you have to think back to your factoring rules in order to do that. If it can't be factored, we use the quadratic formula. So that is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a for your quadratic formula. Again, another formula you might want to have available for the test tomorrow. And any of these concepts could be found in an application problem. So that's a review of the concepts that you're going to find on the test tomorrow. Any questions, anything you want to go over more thoroughly, anything that you want to see worked in addition? More examples of? Are you good to go on all this?
Are you gonna post these in Brightspace?
I'll be posting the notes up on Brightspace, so you'll have to go through the notes to get the formulas. Okay. All right. All right, let's take a break here. See you back in about 10 minutes or so. And then we'll start on the statistics part. Okay?